Students, hello, how are you? I hope you are doing fine. What I am discussing right now is the misconception between the two terms, that is mass of the body and weight of the body. We are going to compare and differentiate the two terms, mass and weight. First of all, as you may have seen, you may have observed that whenever you go to the shopkeeper, if you ask for a bag of potatoes or onions, you say that 5 kg of onions or potatoes, you say it's the weight of that grocery. It's not the weight. That's a wrong thing in physics terms. Weight is a different thing, and mass is different thing. So first of all, while differentiating these two terms, first of all we define these two terms, mass and weight. Mass is the quantity of matter in a body. Number one, quantity of matter in a body. While weight is defined completely in a different way. It is a force. Weight is a force by which Earth attracts every other body having mass m. Weight is a force with which gravity acts on a body of mass m. Number two, mass of a body is a constant value, it's a set value. It doesn't change with respect to place or location. While as far as weight is concerned, weight, it is represented by W, and it is the product of mass of the body times gravitational acceleration of the earth. It means weight depends on the two things, mass times gravitational acceleration. So if we have assumed that m is fixed set, so it means that weight mostly depends on the gravitational acceleration g. So if a body is at the surface of earth where the value of g is around 10 meter per second square, you multiply that value with the mass of the body, you get the weight of the body. So this can be zero, weight can be zero. Now you may think that how could it be zero? So suppose that if an astronaut goes to the space where the gravity of the earth becomes zero, so he becomes weightless. So this value becomes zero. 0 times mass doesn't change. Mass of the astronaut doesn't change at the time. It will be the same as on the earth. So weight of that astronaut will be 0 at a point where the gravity of the earth is 0 on that body. Next thing is mass of any body is a scalar quantity, and weight, as you know that weight is a force, and you know as well that force is a vector quantity. Now let me differentiate between scalar and vector. Scalar are those quantities which can be completely specified by the magnitude as well as unit. For example, 5 kg, 5 is a magnitude and kg is a unit. While if I say the weight, that is force, if it is 10 Newton, so this is magnitude, this is unit, Apart from these two things, we also need the direction. So the direction of this weight is towards the center of the earth. As you know that when you compare this W with the force F, uh, if a force of 10 Newton is acting on certain body, you need to know that what direction it is acting on that body, or the net force. Suppose let's suppose that if a certain force of 10 Newton is acting on the right hand side of the object, let's say a table, and mm, and a force of 5 Newton is acting on the other side, so the net force will be 5 Newton. 10 minus 5, that is 5 Newton. So we conclude from here that it can be completely specified, mass can be completely specified with the magnitude and unit, while weight is a vector quantity. You need to know its direction as well. The other difference is that this mass can be found by an ordinary balance, and for weight you need to have a spring balance. So these are the main differences between these two quantities. I hope you may have understood what I have taught to you. Take care of yourself. See you in the next video. Bye.